This is section 5.4, part A, sum and difference identities. The I can statements for this section: I can use sum and difference identities to evaluate trigonometric functions, and I can use sum and different identities to solve trigonometric equations. So we have sum and difference identities for cosine, sine, and tangent. We use these when we have values that we do not easily find on the unit circle, but if we can find two values that are on the unit circle that we can add together or subtract from each other to find the value that we're looking for, then we can use our unit circle to find the exact values. So we need to find the exact value of each of these trigonometric expressions. So we're looking for the sine of 15. If you look at your unit circle, 15 is not on your unit circle, but 15 is equal to 45 minus 30. So we can rewrite this as the sine of 45 minus 30. This means it's going to be a sine difference problem. If we look at that formula, it's the sine of alpha minus beta is equal to the sine of alpha cosine of beta minus cosine of alpha sine of beta. The first number is your alpha. The second number is your beta. So if we substitute in for the sine of 45 minus 30, we're going to have the sine of 45 cosine of 30 minus cosine of 45 sine of 30. And this is where you're going to look at your unit circle. Remember, sine is the y-coordinate. The y-coordinate of at 45 degrees is radical 2 over 2. Cosine is the x-coordinate. The x-coordinate at 30 degrees is radical 3 over 2. The cosine, or the x-coordinate at 45 degrees, is radical 2 over 2. And the sine, or the y-coordinate at 30 degrees, is equal to 1/2. Now when you're multiplying radicals, you just multiply the numbers that are inside the radicals together. So radical 2 times radical 3 gives me radical 6. 2 times 2 gives me 4. 1 times radical 2 is just radical 2. And 2 times 2 gives us 4. Since the denominators are the same, we can go ahead and do our addition or subtraction as needed. You cannot subtract the two radicals if they are different numbers inside the radicals. So we're just going to write this as radical 6 minus radical 2 all over 4. For this one, we have the tangent of 7 pi over 2. Now, if you're really good with your fractions, you can go ahead and try to find two values that add or subtract on your unit circle to get 7 pi over 2 radians. Or you can convert the radians to degrees before you start. If you want to do that, remember you multiply by 180 over pi. We have a pi in the numerator and a pi in the denominator, so those can cancel. 12 goes into itself once. 12 goes into 180 15 times. And then if you multiply straight across, 7 times 15 is going to give us 105 degrees. So instead of finding the tangent of 7 pi over 12, we can look for the tangent of 105 degrees. And there's a couple different ways on the unit circle you can get to 105. But let's look at the tangent of 60 plus 45. Now this is a tangent sum identity. So our formula for this is the tangent of alpha plus beta is equal to the tangent of alpha plus the tangent of beta all over 1 minus tangent of alpha tangent of beta. Now we have 60 and 45 are our alpha and our beta. So if we plug that in, we're going to get the tangent of 60 plus the tangent of 45 over 1 minus the tangent of 60, tangent of 45. Now remember, tangent is y over x. So if we look at our unit circle, the tangent of 60, at 60 degrees, we have an x-coordinate of 1/2 and a y-coordinate of radical 3 over 2. So the tangent is y over x. So we have radical 3 over 2 over 1/2. The tangent of 45, y over x. 45 has the coordinates of radical 2 over 2 and radical 2 over 2. So y over x. We've already said that the tangent of 60 is radical 3 over 2 over 1/2. And the tangent of 45 is radical 2 over 2 over radical 2 over 2. Now let's go ahead and simplify what those are. So if we're looking at radical 3 over 2 over 1/2, remember if you have a fraction over a fraction, you flip the second one, multiply by the reciprocal. So this is equivalent to radical 3 over 2 times 2 over 1. We have a 2 in the denominator and a 2 in the numerator, so we can cancel those. And if we multiply straight across, we're just going to be left with radical 3. Over here, if we multiply by the reciprocal, we're multiplying by 2 over radical 2. These are going to cancel and leave me with 1. These cancel and leave me with 1. So if we multiply straight across, we're just going to get a value of 1. So if we come back over and simplify, this is going to become radical 3 plus 1 over 1 minus radical 3 times 1. Now we need to get that out of the denominator. This is 1 minus radical 3 times 1. We can go ahead and just get rid of that times 1 because anything times 1 is just itself. Now we need to get rid of the subtraction in the denominator, so we can multiply by the conjugate. So that means we're going to multiply the top and the bottom by 1 plus radical 3. So we are going to have to multiply binomials on top and multiply binomials on bottom, which means we're going to have to FOIL. So we multiply our numerator. We're going to have first, outside, inside, and last. When we simplify this, it's going to give us 2 radical 3 plus, if you square root, it just cancels. Or we can write that as 2 radical 3 plus 4. When we FOIL the denominator, we're going to have first, outside, inside, and last. When we simplify this, it's going to be 1 positive radical 3 and negative radical 3 will cancel. When you square root, it cancels, so there's going to be 1 minus 3, which gives us negative 2. So if we put those back over here, we're going to have 2 radical 3 plus 4 all over negative 2. Now we can simplify this a little bit. 2 goes into itself once, 2 goes into itself once, 2 goes into 4 2 times. We do have that negative, so that is going to have to be moved up with it. And we'll just be left with negative radical 3 minus 2, because we are multiplying that negative by both pieces. An alternating current I in amperes is a certain circuit can be found after t seconds using the following equation, where 160 is a degree measure. We need to rewrite this in terms of a sum of 2 angle measures. So 160 is not on the unit circle, but we can find 2 values to either add or subtract to give us 165. And those values can be multiple things, but let's go ahead and use 120 and 45. Now this is a sine sum problem. So when we rewrite this equation, sine and sum, we're going to say the sine of 120 cosine of 45 plus the cosine of 120 sine of 45. And now we've rewritten the formula in terms of a sum of two angle measures. For part B, we're going to use this sine sum identity to find the exact current after 1 second. So that means we're going to substitute in 1 for our t. Since this is multiplication, when you multiply by 1, that isn't going to change anything. So we can add the 1 in here. But when you multiply by 1, it is going to basically disappear. So we're left with 3 times the sine of 120 degrees is radical 3 over 2. Remember, sine is the y-coordinate. The cosine of 45 degrees, the x-coordinate, is radical 2 over 2. The cosine, or the x-coordinate, of 120 degrees is negative 1/2. And the sine, or the y-coordinate, of 45 degrees is radical 2 over 2. Radical 3 times radical 2 gives us radical 6. 2 times 2 gives us 4. Negative 1 times radical 2 gives us a negative radical 2 over 4. We can multiply that 3 in, and so it's just going to be multiplied by each piece. And then we can make it one subtraction. So it'd be 3 radical 6 minus 3 radical 2 all over 4 because it has the same denominator. If a trigonometric expression has the form of a sum or difference identity, you can use the identity to find an exact value or to simplify an expression by rewriting the expression as a function of a single angle. So if they give you basically an expanded version, you can condense it back down by either doing the sum or the difference and seeing what that value is, and then looking on your unit circle to find the value. If you look at this problem, this is in the form of a tangent sum problem. So that means for this problem, our alpha is 32 and our beta is 13. So if we can condense this back down, that just means we're finding the tangent of 32 plus 13. Now if we do that addition, 32 plus 13 is 45. And 45 is something on our unit circle that we know how to find. Remember, tangent is your y over x. On your unit circle, the y value at 45 is radical 2 over 2. The x value at 45 degrees is radical 2 over 2. Because we have a fraction over a fraction, we're going to multiply by the reciprocal. 2 goes into itself once, 2 goes into itself once. The radical 2's will also reduce to be 1. And if you multiply straight across, we are going to get a solution of 1. Now we can also simplify using this information. So if we look, sine of x, sine of 3x, minus cosine of x, cosine of 3x, looks kind of similar to the cosine sum identity. It's just in the wrong form. So the first thing we can do is factor out a negative 1 from both pieces. Sine of x, sine of 3x divided by negative 1. This gives us negative sine of x, sine of 3x. And a negative cosine x, cosine 3x divided by negative 1 makes it positive. Now we can rearrange this because it is addition or subtraction. Now this looks like our cosine sum identity, because the cosine of alpha plus beta is equal to the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. So in this case, our alpha is x, our beta is 3x. So if we rewrite this, we're going to have negative 1 times the cosine of x plus 3x. X plus 3x is just 4x. So we're just going to have negative cosine of 4x.